Welcome students. In previous video we have seen about the TIG welding process. Now in this video we are going to see about the MIG welding process, which is metal inert gas welding, or more appropriately we can call it as the gas metal arc welding. So the thing is that the process is involving or using the consumable electrode. In TIG the electrode was not consumable, but here we are going to consume the electrode. That's why the word metal comes into the title. And the processes, the shielding arc welding processes, whichever the process is, uses the consumable electrode that can be categorized into this MIG welding technique. Okay, the best example you can say the flux core arc welding technique. The wire is not a solid one, it is hollow one, and through the hollow wire we are providing the fluxes into the weld so that the contamination can be done. Okay, so let us see what is there in MIG. Okay, so MIG welding, or GMAW in short, gas metal arc welding or metal inert gas welding process. So definitely here the electrode is going to consume, and it is in the form of wire. So wire electrode, which is mounted on the wire reel, or this is also known as the welding spool, and this wire is feeding through this feed control mechanism, or the servo controllers are there. These are also the feed rollers, you can say, or feed controllers. Okay, this is the torch, and this is the wire is passing through this rubber pad. So what any impurities if present onto the wire, that can be squeezed out by these rubber pads, and only the pure wire is going to feed into the weld pool. Okay, so this is the torch. In that we are supplying the inert gases. Okay, and of course there is a power source. So I will show like this. So it is connected here. Power supply. Okay, so like that for the MIG welding. Okay, so this is the wire which is wounded on this wire reel, and this wire is continuously fed into the weld pool through this feeding mechanism or servo controllers, and wire is getting cleaned by these rubber pads. Okay, and we are continuously supplying the inert gases and to contaminate, to safeguard the weld pool from this atmospheric contamination. So see here, this can be the shielding from these inert gases. Okay, so if you look at this process, okay, metal arc welding process, so here the electrode is going to consume. Okay, and if you look at the power source which is used for this MIG welding process, is definitely the DC power source, direct current here used. Okay, please remember, in MIG welding direct current is used. We are not going with the alternating current. Likewise, the TIG welding we were using the AC or DC, but here direct current, and the polarity is straight polarity. Please remember, very important, the MIG welding process uses the direct current with electrode positive. Direct current, electrode positive. Okay, why this direct current electrode positive? Definitely it here, when the electrode is given with the positive, so what happened, we will get the maximum metal deposition rate, and of course here the wire is going to melt. We want to melt the wire, so definitely with this polarity we are going to get maximum deposition rate. We are going to get maximum deposition rate, very smooth metal transfer. Okay, this is the advantage that we are going to get with this direct current with the electrode positive, that is with the reverse polarity. This is the reverse polarity. Direct current electrode negative. Yes, we can also use the direct current electrode negative, that is straight polarity, but thing is that the arc is highly unstable in case of the direct current electronegative, and there are chances of having the large amount of spatter. So that's why we are not generally going for this direct current electronegative terminal. In some manner, if you want to go for the direct current electronegative for the MIG welding, then you can add the mixture of calcium or titanium oxide into the coating of the electrode, so that you can get the good welding with the steels. So that is also done with the direct current electronegative, that is with the straight polarity. We can also do this MIG welding, but the thing is that we have to add some mixtures like calcium and titanium oxide into the coating of this wire, okay, so that you will get the good quality of weld. But please remember, we are using direct current with electrode positive as a power source for the MIG welding operation, and why we are getting this, these are the advantage by using the DCEP or reverse polarity. Okay, now come to the shielded gases. Now come to the inert gases or shielding gases for the MIG welding process. So see, there are the variety of shielding gases are available, or inert gases are available. We are having argon, we are having helium, we are having carbon dioxide, oxygen, nitrogen, or again the mixtures of these gases also we can made to act them as a shielded gas or inert gas around the weld pool. Okay, now let us talk about each of these one by one in this MIG welding. So see, if we talk about the argon, okay, if you talk about the argon, so argon is reducing the spatter, and it concentrates the arc. Students, I request you to please note down whatever the points I am saying about all the things. You try to note down, okay, by pausing the video. So please remember, the argon, when we select the argon, so what are the special things about argon? So argon is concentrating the arc, it reduces the spatter. Also, it increases the depth of penetration. See, it increases the depth of penetration. That's why it is most widely or most commonly used inert gas, argon. The next thing is that argon is having the less thermal conductivity. So it is carrying the heat from the weld pool to the weld zone very slowly. And that's why this argon is suitable for the joining of the thin, small size plates. Okay, please remember. And the thing is that, right, a very important thing, that the argon ionizes very easily, so that we are requiring the minimum voltages in the process. Please remember, these are the some points about the argon. Now let us take the helium. If I take the helium, so helium, yes, of course, it is expensive gas. It is the expensive gas among all the inert gases, and it is having the better thermal conductivity, and because of that it can carry the heat very nicely. So it is used for the thicker plates, when you are going to join thicker plates. So argon, helium having a very good thermal conductivity, and that's why the materials which are having a very high thermal conductivity, or say good thermal conductivity, are preferred for this helium, okay, like copper and magnesium. Okay, so again, one more thing about the helium is that helium gives the very high deposition rate, metal deposition rate, because it is having the very high current carrying capacity. Please remember, it is also having very high current capacity. That's why it is giving us the high metal deposition rate. So this is about the helium. Now if I talk about the carbon dioxide, so this is the least expensive gas in all these inert gases. Amongst all, it is a least expensive gas, and the thing is that we have to use here the short arc, so that the arc directly get directly into the crater. Crater means the depression made by the arc onto the workpiece. This is the arc crater. Okay, because it is highly unstable. This carbon dioxide is unstable gas, so it is prefer to have the short arc so that metal can be directly go into the arc cutter. The another thing about the carbon dioxide is that whenever you use the carbon dioxide as a shielding gas, so it decomposes into carbon dioxide is get decomposed around. See, if I using the carbon dioxide, so whatever the amount of carbon dioxide, out of that 7.5% of carbon dioxide get consumed or decomposes into carbon monoxide and oxygen. Please remember, so this is a thing which again introduce the deoxidizers in the material in the welding process. Okay, because it decomposes into the carbon monoxide and oxide, we need to use some deoxidizers with this inert gas. For example, we are using the aluminum and silicon as a deoxidizers in case of you are using the carbon dioxide as a shielding gas. And if you talk about the mixture of the gases, say argon with the helium, argon with the oxygen, argon with the CO2, so these are the again mixtures of the inert gases which can be used for the special purpose, special applications. In that case, we are using these shielding gases. Okay, so these are the shielding gases which can be used in this metal inert gas welding, or even also TIG welding. We are most commonly used in the TIG. Most popularly argon is used. It is least expensive gas, and I told you about this argon gas. Okay, now when you talk about we talk about the setup, we talk about the power source, we talk about the inert gases which are used in the process. Now if I talk about the wire, okay, so this electrode in the form of wire, definitely it is manufactured or produced by the wire drawing operation. And if you see the diameter of this wire, it is generally used from 0.5 to 3.2 millimeter. Please remember. Okay, so what is the size or range of this electrode wire used in the MIG welding? It is from 0.5 to 3.2 millimeter, and of course we have to clean the wire, okay, before taking it into the application. Okay, why? Because whenever in the wire drawing process, any layer of say lubrication, any dust particle which is present onto that, it will definitely try to come into the weld put. So we should thoroughly clean the wire before taking it into the operation. Okay, now here the by using this MIG welding process, so in a single pass we can join the plates having a thickness up to 30 millimeter. Please remember, in a single pass we can go up to 30 millimeter plate thickness. Okay, we can weld easily up to 30 millimeter. Again we can go up to more than 30 millimeter, but what we have to do, we have to decrease the weld speed, so that again we can have the maximum time that particular area, and we can go the thickness above 30 millimeter nicely. But thing is that whenever you decrease the speed of welding in the MIG welding process, so this arc having the force on this welding weld pool, and that's why there are chances of getting this material which is molten material come out and spread over the non-welded portion, causing the spatter. Okay, so that is the reason why we are generally using this welding technique up to 30 millimeter thickness plates. Okay, and of course this welding technique is basically done for the highly reactive materials, for the welding of highly reactive materials like aluminum and magnesium. Okay, so these are the things, or these are the facts about the MIG welding. Any question come, you can able to answer. Okay, so this is the MIG welding sheet. Thank you.